We have created an instant messenger visualization called IMVis for MSN Messenger. All of our messenger contacts are placed within a 3D tunnel to provide us with awareness information. This awareness helps us decide if and when to move into conversation. Availability is one of the most important features of awareness, so we have mapped it to several visual cues. First, contacts that are more available are more prominent. They're larger and in focus and appear around the outside edge of the 3D tunnel. Those contacts that are less available are smaller, become blurred, and are closer to the vanishing point within the tunnel. As contacts become more available, they will animate towards the outside edge of the tunnel, and as they become less available, they will animate towards the vanishing point of the tunnel. Animation and audio cues are used to attract your attention to this awareness information, even if it is in your periphery. We also represent availability with representations of each contact's availability state. Contacts can choose to use updating video snapshots to provide a rich amount of awareness, or they can choose to use predefined images. I could select a file from my local hard drive, and my image will be replaced, or I can select to capture a picture from a locally attached PC camera. Currently, we use MSN Messenger's 7 availability states and an attached PC camera to determine availability, although we could use more accurate sensing-based technology, but this does not affect the visualization. To help preserve privacy, we use a blurring technique which will blur video snapshots or images of our contacts when they are less available. As messages arrive from my contacts, a conversation bubble is placed next to the contact who sent the message, so there's a direct link between the message and the person who sent it. As message bubbles disappear, stars appear around the top left corner of the contact. Over time, these will animate towards the vanishing point of the tunnel, so at a distance I can tell my frequency of interaction and its recency. Users are also able to create their own spatial grouping of contacts. They could group family, friends, or coworkers together just by simply dragging them throughout the tunnel. While contacts are being moved, we use a collision detection algorithm to avoid occlusion. Contacts slide out of the way and then return to their previous location. We understand that people don't always have the same level of interest in their contacts throughout a day. This interest will come and go. Contacts who you are less interested in right now can be dragged towards the vanishing point of the tunnel. Those you are more interested in can be dragged towards the outside edge of the tunnel. Contacts that are of less interest reflect that interest by no longer generating conversation bubbles, although Messenger still keeps track of the conversation, and if they subsequently go offline and then come back online, they will only go as far as your previously set interest level. While IMVis is one of our first prototypes, we offer several critiques which may aid in our redesign of the system. First, we let contacts choose how they represent themselves by selecting pictures or video snapshots. By looking at the pictures selected, it's clear there's quite a broad range of pictures that people choose, and it's often not clear what each picture represents. It is often difficult to tell whether a contact is being of less interest or less availability if they're blurred somewhat and smaller. For contacts that are very far away from the user and close to the vanishing point, it's often difficult to even see who the contact is because they're very small and very blurry. IMVis was designed to support small groups and can easily show around 8 contacts, but probably no more than 30 because clutter becomes an issue. However, these sizes are typical to most Messenger contact lists. IMVis does take up more screen real estate than typical Messenger buddy lists, and is for this reason appropriate for a secondary display. We are not suggesting the visualization we have presented is necessarily the best way to go, but are rather exploring alternate metaphors for visualizations of media spaces and multimedia contact lists. We are also prototyping other 3D visualizations for IM, such as George Robertson's Data Mountain. Here, contacts move up and down on an inclined plane, where contacts at the front have a higher availability status than those further back.